All right, this is pre-calculus help on your alternate assessment called Exploration 3.4. I'm going to just give you a couple of hints on how to get started with this. So the front page is gives you some directions. The first thing I want to point out is that I really should have used the word here integer. For each problem, evaluate the given function for all integer values between negative 15 and positive 15. And I'll show you what I mean by that in just a minute. Here on the front page are what are called parent graphs of 9 different parent functions. You are, as we proceed through section 3.4, going to be expected to know these shapes of these different parent graphs. In this exploration, I am hoping that by doing some evaluations and plotting the points, you get a feel of why each parent function is the shape that it is. These 9 graphs are actually the answers to problems 1 through 9, so I hope that nobody gets problems 1 through 9 wrong. After 9, we start to do some transformations of those parent graphs. And there, you're going to have to use a little bit more brain power to understand what's happening and what type of transformation is happening. But the graph will always have the same shape as the parent graph. I'm going to do problems 9, 10, and 12 for you right now. And so again, not only should you get problems 1 through 9 correct, you should also get problems 10 and 12 because I'm about to show you those answers as well. All right, so I'm going to flip to problem 9. All right, here it is. Okay. What I've done is I've already calculated all 15 of these y values for you. You should be rounding to one place after the decimal. I'm getting a calculator. Right? So if I wanted to find, let me see if I can see my calculator screen. Turn the light on. If I wanted to find the y for x is negative 15, this says negative 15 over here. Okay. If I want to find y when x is negative 15, I'm just going to go to math. I'm going to choose the cubic root, which is choice 4, and I'm going to plug in negative 15. Okay. That gives me negative 2.466. So if I want to round that to one place after the decimal, it becomes negative 2.5. So that's what I did there. And like I said, I already, for the sake of time, calculated all of those values. All right, so I'm going to plot those points. Let's see, negative 15, negative 2.5. So that's somewhere between negative 3 and negative 2. Same thing goes for negative 2.4 and negative 2.4 again. Remember, those are estimations or rounded answers. Negative 2.3, negative 2.2, negative 2.2, negative 2.1, negative 2. All right, so that one is right there at the crosshairs. Negative 1.9, that's between negative 1 and negative 2. Negative 1.8, negative 1.7, negative 1.6, negative 1.4, negative 1.3, negative 1 right here. 0, 1, 1.3 is between 1 and 2. 1.4, 1.6, 1.7, 1.8, 1.9, 2. 2.1, 2.2, 2.2, 2.3, 2.4, 2.4, 2.5. Okay, so my line, or it's not a line, it's a curve. My curve is a little too many curves in it, but those are going to be the struggles that you face when you are estimating. This is the answer to what that graph should look like. It should be a nice concave, well, I guess it's concave to the right here, and it's concave to the left there, but nice smooth curve. All right, so now what I want to do is I want to see if I can't connect them, making a nice smooth curve. All right, that's the answer to problem 9. All right, problem 10. All right, this one's a transformation. Okay, so I'm taking that cubic root function and I'm moving it somewhere. So I just want to, we'll learn the rules about how you move them when we get into section 3.4. But for right now, I just want to use these points that I calculated. So again, maybe I should show you how to do this. I want to take, this is negative 15, and I want to plug in negative 15 into this expression. All right, so I'm doing the cubic root of negative 15, and then close the parentheses because only the negative 15 is taking the cubic root. And then add 2 to that answer, okay? So I got a negative 4.66, so I rounded that to a negative 0.5, right? So I'm going to graph these points. At negative 15, I've got negative 0.5. That's somewhere between negative 1 and 0. Negative 0.4, negative 0.4, negative 0.3, negative 0.2, negative 0.2, negative 0.1, 0, 0.1, 0.2, 0.3, 0.4, 0.6, 0.7, 1, 2, 3, 3.3, that's between 3 and 4, 3.4, 3.6, 3.7, 3.8, 3.9, 4, okay, 4.1 is between 4 and 5, 4.2, 4.2, 4.3, 4.4, 4.4, 4.5. All right, so we've got the same shape because the parent graph is the cubic root of x. Here's the parent graph. Okay, so it's going to have the same shape as problem number 9, but it got stretched or moved somehow. So here, this is concave up to the right of 0, concave down, I'm talking about x equals 0, or concave to the right of 0, concave to the left of 0. So basically this graph just scooted up too. All right, I said I would do one more problem. It's problem number 12. This one's a quadratic. You should know a lot about quadratics already. You did a lot of graphing of quadratics in your Algebra 2 class. The only reason I chose to do this problem is because I wanted to just show you that you're not going to be able to graph these, and that's okay. The first number that I could fit on my graph, well, 15 is here. So I could just imagine that 16 would be one up from there. So I've got negative 3, positive 16 would be there. Negative 2 at 9. Negative 2, 9. Negative 1, 4. 0, 1. 1, 0. 2, 1. 3, 4. 4, 9. and 516. So you know the shape of a quadratic equation is a parabola. Here, my vertex is at 1, 0. So this shifted to the right 1. Okay. All right, that's it. Do your projects.